in the exam we can be given inequalities to calculate. Now A, as it states here, we can be asked to show our solution set on a number line, and in B we're going to show our solution set sorry, by using interval notation. So let's quickly run through these. Now in example 1, as I said, when working with inequalities, we manipulate it, or we do the same thing as we would do in an equation. Hence, we see a 2 being added to x, so we're going to do the opposite of that. So I'm going to say x plus 2 minus 2 is greater than 5 minus 2. Now, I know that a positive 2 will cancel out with a negative 2. Therefore, x must be greater than 5 minus 2 will give me a 3. Now, in part A, they're asking us to show this on a number line. So let's quickly do that. So I have some number lines here. So let's just show what this means, how this would look on a number line. So since I am working with 3, x must be greater than 3. I can start at 2. So I'm going to put a 2 here. Then I have 3, 4, 5, 6. Now I'm starting at, let me use a color, let me use that blue. I'm starting at 3, x must be greater than 3. So since x is greater than 3, I must use an open circle, okay? And then I am going above 3. So I'm taking all the values above 3 and I'm going up to positive infinity. Now also they have asked us to, so this would be part A. We have showed that information on a number line. Now we could ask to write this information also in interval notation. So part B now, I'm going to represent it in interval notation. So since it's saying x is greater than 3, then it simply means, and it's clear on the number line that x is taking all the values. But if x is greater than 3, I must use my parenthesis, and then I'm going to put my 3, comma, and then I'm going to put my infinity sign, and I'm going to close by using my parenthesis again, because I will never touch infinity. Once I'm using the infinity sign, I must use my parenthesis, and it states that x is greater than 3, so I can't touch 3 also. Hence, I have an open circle. Let's move on quickly to the second. Now again, we're going to just manipulate this, or work just do what we usually do in an equation when trying to find the value of the variable. So we see a y minus 4, so the opposite of a minus 4 would be a positive 4. So here I would have y minus 4 plus 4 is less than minus 10, and we added 4 to this side, so I must add another 4 to that side. I know a positive 4 will cancel out with a negative 4, hence y must be less than negative 10 plus 4 will give me a negative 6. Okay, so y is less than negative 6. Again, we can be asked to show that information on a number line. So again, here I'm just going to pull up my number line, my second number line, to show this information. Okay, so let me quickly just get this out of the way. So I have, let me change my color. So since y is less than negative 6, it simply means then my boundary is negative 6. So let me put a negative 5 here, then I can have a negative 6 there, then I can have a negative 7, negative 8, negative 9. However, 9 must be less than negative 6. So this would indicate that my boundary is negative 6 and I'm going less than negative 6. So I must go in to my left in that direction. Okay, and since it's less than, I'm going to be going to negative infinity. Okay, and that's how you would represent that. Remember, once it's less than or greater than, the circles must be open. They aren't shaded, if you notice. Okay, now that's part A. Let's look at part B. So this is part A. Let's look at part B quickly. Part B, we're asked to again to write this information in interval notation. So y is less than negative 6. So again, since I'm going to negative infinity, I'm going to open my parenthesis, put my negative infinity sign, comma, put my negative 6, my boundary, negative 6, and I'm going to close my parenthesis. Okay, and that's it. It's that easy. Now again, we can look at this exercise where, and just let me change up this a bit to make it a bit more interesting. Okay, let me change this a bit. I'm going to change this value here from 5, and I'm going to put, let me put 8. Yes, that seems to be a pretty more interesting value. So let me use a 8 there. Okay, now again, we are going to manipulate this inequality by saying 2x plus 3, and I'm going to subtract 3 from both sides. It's less than or equal to 8 minus 3. Okay, I know that a positive 3 will cancel out with a negative 3, so really I'm left with 2x is less than or equal to 8 minus 3 will leave me with a 5. So now I have a 2x is less than or equal to 5, so I must divide through by 2. So I'm dividing both sides by 2. This 2 will cancel that 2. Hence, x is less than or equal to, x is less than or equal to 2 into 5 goes 2 times, remainder 1 over 2. So in this case, x is less than or equal to 2.5. Now, yes, we can graph this on a number line quickly. So let me pull up my number line. Okay, quickly. So let's pull up that. So really, I made this a little bit more interesting just to show you how we get around these things quite easily. Now look carefully. If I'm going to put a 0 here, my origin is there, and this is 1, and this would be 2. Okay, now if this point here is 2, then that simply means then that halfway between 2, so here would be 3. Let me just finish that. Here would be 3, and here would be 4. But if I'm working with x is less than or equal to 2.5, it simply means then that 2.5 would fall halfway between 2 and 3. So in the middle here, I would have my 2.5 would fall somewhere there. Okay, let me use another color. My 2.5 would fall somewhere here in the middle of 2 and 3. So all I'm doing now is to graph this on a number line. So I'm going to use my circle. Okay, but if you notice now, I'm using a less than or equal to. Sorry about that. A less than or equal to. So whenever using a less than or equal to, I must now shade my circle. Okay, to show that I'm using a less than or equal to. So I'm going to shade that, and I'm moving to my left because it's less than or equal to. Put on my arrowheads and indicate that I'm going to negative infinity, and it's that easy. Now again, since I'm going to negative infinity, so that was part A in that case, so this is part B now. So I'm going to negative infinity, so I'm going to use my parenthesis, put my negative infinity sign, close, comma rather, and then I'm going to put my 2.5 because 2.5 is my boundary. And then since it's less than or equal to, I must use my braces, my square bracket. Okay, and that's it. Now in this case, in the last example that I will be working, 5y, yes, 5y over 2 minus 6. Now quickly, let's just manipulate that. Here this would give us a 5y over 2 minus 6, and we would add 6 to both sides, is greater than or equal to 14, and I would have to add another 6 to this side, plus 6. Now I know that a positive 6 would cancel out with a negative 6, so really I'm left with 5y all over 2, and that is greater than or equal to 14 plus 6 would give me a 20. Now I have a fraction here. I can always turn this into a fraction and cross multiply. Okay, so 5y times 1 would give me 5y, and 2 times 20 is 5y is greater than or equal to 2 times 20 would give me a 40. Now 5 is multiplying y, so I'm going to have to divide through by 5. So I'm dividing both sides of my equation, my inequality rather, by 5. So let me just move this down a bit because I may need a little bit more space to work with. So here, really what we have left is y is greater than or equal to, and we know that 40 divided by 5, 5 into itself once, 5 into 40 goes 8 times. So y must be greater than or equal to 8. Now let me just pull this down some more so that we can get a little space here to work with. Okay guys, now all I'm doing here, oops, I tend to have one more number line that I'm not gonna need that, so let's get rid of it. Okay, good. Now we can represent this on a number line quickly, and let me do that. We have, this is part A, and we have here y must be greater than or equal to 8. So let's say that this is 7, this is 8, this is 9, 10, and 11. Now since y is greater than, my boundary is 8, so I'm going to start at my boundary. However, in this case it is greater than or equal to, so I must shade it, okay, to indicate that 8 is included in this solution set, and I'm going up because it is greater than or equal to, and I'm going to infinity, and it's really that easy. So now part B, I must write it in interval notation. So now I'm going to have my, since it's greater than or equal to and 8 is included, I must have my square brackets here, and then I'm going to have my 8 comma, and I'm going up to positive infinity, so I must close with my parenthesis. And that is it. That's how we represent inequalities on a number line. Well, in this case we're dealing with an infinite set, so that is how we represent an infinite interval on a number line, or using interval notation. In the next lesson we're going to be looking at how we represent finite intervals and on a number line and using interval notations. Okay, bye bye.